The IMPOWER function within Excel allows us to raise a complex number to a real number's power. So let me show you. We write =IMPOWER, and then we need to provide two arguments. The first of which is the base, and that would be the complex number. So I have the complex number here in column A. Then the second argument is whichever power we want to raise this complex number to. Now do keep in mind, this needs to be a numeric number, so it must be recognized as a number within Excel, meaning it must be a real number. You cannot use a complex number as a power. So in this case, I will be using 2. So we will be squaring each complex number. I close the parentheses, press enter, and I will be pulling this downwards. Now, for most of these results, we get clean results, like over here, 3 plus 4i, 4, 3 minus 4i. But for some of these results, we get these numbers that have like a huge exponent, like e to the minus 16th, right? What this means is like 0 with 16 zeros and then 49005. So this might just as well be 0 plus 8i. Same thing here, 0 minus 8i. Same here, 0 plus 2i, etc. Okay, now one way how we could manually calculate bringing a complex number to a certain power is to transform our complex number from its rectangle form, such as we can see here in column A, to its exponential form, where it's written like r times e to the power theta I, where we call r the modulus, being the distance from our point on the complex plane to the center, and theta being the angle at which the point is situated compared to the x-axis. Now on the complex plane, the x-axis represents the real part and the y-axis represents the imaginary part. So for this, we will have to calculate the modulus and the argument of our complex number. Now for both of these, an Excel function exists specifically to do this. So to get the modulus, we can use the IMABS function, which will return the absolute value of a complex number. So I supply the complex number as the only argument. I pull this down and out comes the modulus. Now we can do a similar approach for the theta being the angle or the argument of our complex number. So I write argument, and this will return the argument expressed in radians of our complex number. So once again, only one argument, and we input that complex number as the argument, and we pull this downwards. Okay, so now we have sufficient information to write our complex number in the exponential form. So what would that look like? Well, let me round down this r to 2 digits. And then I want to multiply this with e to the power Now to do this, I will have to use string concatenation, right? Because complex numbers are not considered as numbers, but are considered as being text. So I take e to the power, and then in between brackets, I write theta. Now theta is equal to whatever we have in column D, being the argument. So I will also round this to 2 digits. So we take theta, round it to 2 digits. Then I concatenate this with I, and I close the parentheses. Now do keep in mind that these ampersands are used to concatenate strings, and the double quotation marks are used to represent strings. Okay, I press enter. There we have the result. Let's pull this through. And there we have the results, our complex number represented within the exponential form. Now let's use this exponential form to then also square it. Okay, so how are we going to do this? Well, first we need to multiply two numbers, being r, or the modulus, multiplied with the exponential of theta I. Okay, so we can do this with the mProduct function, which allows us to multiply multiple complex numbers. The first number will be r, or the modulus, and then the second number will be the exponential, so we can use the imexp function, where we multiply theta, or the argument, with I. So I use once again the mProduct function. So I multiply I times theta, which was applied here in column D, and then I close all of these parentheses. I press enter, and if I now pull this down, you can see we get exactly the same result as our initial complex number. Sometimes there's a small rounding error, as you can see over here, where we're getting 0.9999999i, whereas we would have expected 1i. But these are just some rounding errors when working with complex numbers in Excel. Okay, so if we now want to square this number, all we have to do is to multiply our exponent here of theta I with 2. And we also need to bring the r, being the modulus, to the power of 2. So I can just do it like this. I don't need to use a special IMPOWER functionality because the modulus is a real number and not a complex number. So I press enter and I will be pulling this downwards. And as you can see, we're getting exactly the same results. You can see for this, it matches exactly. Now you might be saying it's not exactly true because this first result here does seem to be different, but do keep in mind that this e to the power minus 16 and this e to the power minus 14 means there are 14 zeros in our decimal. It's like 0.000000, etc. So basically 0. So what this really means is just 8i, just like it is over here, right? So given some rounding, we are getting exactly the same number. So the IMPOWER function is an excellent function to use whenever you want to raise a complex number to a real power, where the first argument of the IMPOWER function is the complex number and the second argument is a real number to which you want to raise this complex number. Thanks for subscribing and leaving an optional tip. Consider watching this video next.